It's like a puzzle. Yeah. All right, we're back live. Okay. Just a reminder, I have you again on Monday. But when I have you on Monday, you'll have come in after having just eaten. Because on Monday, we will have the full school day to 150. And between second and third, there will be one giant common lunch. I'm sure you guys have heard about the locations for the common lunch. Kinda. Wait, what's up? I'm not certain because they will have the cafeteria, they will have the auxiliary gym, they will have the library, and I think, don't quote me on this, but I think that on good weather days, they may end up using the grass courtyard and possibly this courtyard because they've just set up picnic tables out there. Do you guys know that? They set up picnic tables between the two buildings. Yeah. So that's why I'm saying I think out there on good weather days, you know. So yeah, you will be pretty much spread out, but you know, it's not like you won't be able to like, you know, I don't think you'll be able to like hang out in like stairwells or anything like that. I don't know. But we'll figure this junk out. It'd be nice, but at least you'll have come into my classroom having eaten, and then we will proceed with the mathematics that we need to proceed with. Yay, oh happy day, oh happy day. Okay. First, you had an assignment due for me. Just as a reminder, it looks like, only 5 of you have turned that one in. That one was due today. I had assigned that one on Monday, and I made it due Friday. No, I didn't make it due Friday. I made it due Thursday. Today is Thursday. Yes. Make sure you are jumping on that. You need to get the practice with that. The what? Horrible. Oh, my heart. Goodness. My goal for today's class period is kind of twofold. Number one, I want to go over a couple of those problems from that homework that is due today. Not all of them, but at least a couple of them, to review them and to talk about what is needed of you in preparation for a minor assessment that I'm going to be giving you. It is going to be a quizzes minor assessment, but I am going to be assigning that before I leave the building today. So please keep that in mind. So number one, I would like to review a couple of questions from that homework with you in preparation for this minor assessment that I'm going to assign you. But then with the second part of this class period, I would like to take a small step forward and to show you the beginnings of graphing these problems. It's going to be nice, mainly for me. If you're joining us in the chat, please make sure that you are leaving a comment. That would be fantastic if you would. Let's see where this homework is going to lead us. So let me flip my camera over. Get to your class period. Here we go. Class work. Boom. View the assignment. Instructions. There it is. There are the instructions for the assignment, which is due today. You had worksheet 8.1, which I'm going to open right there. Let me close out these Enigma projects. There we go. And you had worksheet 8.2, which I'm going to be opening in a moment. Now, for those of you that worked on it, would you say that there was one problem in particular that caused you a lot of stress? Could you pick one from the 8.1 side? You had to do numbers 1, 4, 7, 9, and 18. I'm a couple from both, maybe. 8.1, you said 18, right? Okay, we're just looking at the both of them right there. Let me talk briefly about number 1 then. Let me zoom in as best I can right here. Again, these problems are available to you through the Google Classroom. But there is number one right there. Something I want you to notice about number one. What operations are in the problem? And that's it, right? Multiplication and division, and that's it. Those are the only operations that are in the problem. So we don't have to worry about any addition, subtraction issues going on here. Since it's only multiplication, division, we can cancel stuff out the way that we want to. 9 over 27. 9 over 27 is a single fraction that we can reduce. What can you divide out of 9 and 27? You definitely do a 3. Can you do anything larger? A 9. You can divide both by 9, right? So if you divide that by 9, you get 1. And if you divide that by 9, you get 3. I'm just kind of putting my little scratch work up here. I get an a squared on top. How many a's is that? How many a's are actually being multiplied on the top of the problem? How many a's are being multiplied on the bottom? Who wins, top or bottom? By how many? Yeah. I'll say that again a little bit slower just because I know that I was speaking rather quickly and people in the chat are like, what's going on? Because they didn't hear any of your responses, of course. But what I asked was, how many a's are being multiplied on top? And you guys said there are 2 of them, a times a. How many a's are being multiplied on bottom? There's 4 of them, a, and a. My question was, who wins, top or bottom? And you said bottom. And I said, by how many? And you said 2. Well, if the bottom wins by 2, there's your a squared. Notice where it is on the bottom of that problem. You could do the exact same logic with the b's. Well, the top has b times b times b. The bottom has 4 of them. The bottom is going to win by 1. Big question. What do I do with that c? It just stays there. Ultimately, what is left on top of this fraction? Yeah. Over a 3a squared bc. That's all that they wanted you to do on that particular problem. Again, remember, this was a homework. This was a homework. It is not due until 2 o'clock, but this is a homework, and it is not graded on correctness. It is graded on completion, but I wanted you to get the practice with seeing how these problems play out. I'm sorry, you said 18, right? 18. I just want to make sure I got the right number. So I'm going to go to number 18 now on the same page. Like I said, I'm not going to go over every single one, but I want to give you an opportunity to kind of get a head start on this, to review a couple of these problems, to help you with your understanding. Here is number 18. There we go. The first thing, actually, no, there's 2 things that strike me immediately. There's 2 things that strike me immediately. First, the division sign. The division sign. The division sign I want to change to a multiplication, and I will. I will change that division sign to a multiplication at some point. But if I do change it to a multiplication sign, I am going to have to flip the second fraction. Keep, change, flip. So that'll take care of the division sign. That's one of the first thing that pops out to me. The second thing that pops out to me that I don't really like is that 9 minus a squared. I don't like that 9 minus a squared. I would rather that 9 minus a squared look like something else. Now, just to give you a reminder, I believe several class periods ago, I showed you something like this. Several class periods ago, I think those are the numbers and letters that we used in our notes, in which I showed you how to take something like 6 minus x take out or reverse it and take out a factor of -1. So I was like, okay, I don't like the way this looks, so I'll make it -x plus 6, but then I'll factor out a -1 and make it x minus 6. I am going to do something very similar to this 9 minus a squared. Something very similar. I'm going to take that 9 minus a squared, and I'm going to make it a -a squared plus 9. But I am also going to factor out a -1. So if I factor out a -1, the brand new fraction should be -1 parentheses a squared minus 9. Now, I'm going to have to change that. I'm going to have to fix that. I'm going to have to adjust it. I'm going to have to eventually factor that portion of the problem. I'm going to have to factor it, and I'll deal with that in a minute. Let me write the rest of this junk out real quick so that I can fix it later. I didn't change the bottom left. I want to change that to a multiplication. In order to change it to a multiplication, I'm going to flip this junk. Okay. So far, I've only taken care of the first two things that popped into my head. I noticed that the 9 minus a squared looked terrible, and I wanted to fix it. And I noticed the division sign. I have fixed both of them. Now it is time to factor. Can you give me two numbers that multiply to 9? I'm sorry, that multiply to -9 and add up to 0? Okay, so hold on. There's the top left of the problem now. There's the top left. You said -3 and 3. The only reason I'm allowed to do that is because this is a 1a squared. Same thing right here. Two numbers that multiply to 6 and add up to 5. Can you think of two numbers that multiply to 6 and add up to 5? 3 and 2. A plus 3, a minus 2. I'm sorry, plus 2. Goodness gracious. They both have to be positive. They have to multiply to a positive and add up to a positive. I don't know why I was thinking minus. Mr. Markey, these two fractions are not quadratics. I know. What's the GCF? What's the greatest common factor of the top right side of this problem? What number could you divide out of both of these terms? Yeah. 5 parentheses a plus 2 over, what about down here? What could you divide out of both of them? Yeah. A minus 3. Now, I'm going to have to start canceling some junk out. I'm going to have to start simplifying some things down in a moment, but let me recap exactly what we did. Number one, I looked at the original problem, and I did not like the way the 9 minus a squared looked. So I decided to reverse it, and I decided to divide out a -1 as a greatest common factor because it made my life easier. The second thing that I did was I changed that division sign to a multiplication sign and flipped that second fraction. Keep, change, flip. Then it was time for factoring. I used a modified Tucker method. Numbers that multiplied to -9 and added up to 0. There they are. Two numbers that multiplied to 6 and added up to 5. There they are. The only reason I'm allowed to do that is because of the 1 that's here. Then we took out a greatest common factor out of both of these down there. Now we can start canceling junk out. A plus 3, a plus 3, a plus 2, a plus 2, a minus 3, a minus 3. What the heck is my final answer? What's the only thing that's left? Say again one more time. Not just 5 over 2. Yeah, because that negative is still there. This is the proper process for going through that problem. There's always more than one way to kind of do this problem. Always more than one way. But this is probably the most straightforward way of doing this problem. Taking care of things one step at a time. The division sign. The 9 minus a squared, I didn't like the way it looked. I changed it. Factor, 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 factor. Then cancel all that junk out. Okay. 8.2. Worksheet 8.2. Is there, I'd like to try to go over one problem. If we have to go over more, maybe, but I definitely want to try to go over like not the worst of it, but the one that gave you the most issues. What from 8.2, and I'll bring that worksheet up in a moment. What from 8.2 would you say, please help me, help? Let me bring that thing up over here. It's right there. There it is. You had to do numbers 10, 13, and 21. Sure. Oh, that's 24. There we go. It's 21. Bring that up. There we go. So there's number 21. Adding and subtracting. I'm looking at the denominators. First thing I notice, 2 of them have an n in common. The next thing I notice, 5, 4, and 10. 5, 4, and 10. Is there a number, a least common multiple? A multiple of 4, 5, and 10 that we could use to kind of bring them all to a common denominator? There is one number that I have in mind, but we can figure that out. A number that is divisible by 5, 4, and 10. 20. And now, because 2 of them have an n in common, yeah, I have to give it to the 4 as well. The common divisor, or the divisor, I'm sorry, not the common divisor, the common denominator is 20n. It's 20 because of the 5, 4, and 10. It's n because, well, 2 of them have an n in common. But like you just said, I'm going to have to give an n to the middle one as well. If I'm aiming for 20n, then I'm going to multiply this first fraction by 4 over 4. I'm going to multiply this second fraction by 5n over 5n. And I'm going to multiply this third fraction by 2 over 2. I end up getting what? 4 over 20n minus 15n over 20n plus 14 over 20n. They would all have the same denominator. I just have to combine like terms now. Once I combine like terms, I'm going to get negative 15n plus 18 over 20n. Unfortunately, that's all I can do. You can bring all 3 of them together into a single fraction. There is one problem that I would like you, not from the homework, but there is one problem I would like to do with you all together. It's got to find the right one here. Boom. No, definitely not that one. Where did I put you? There you are. Ha ha! Okay. Ladies and gentlemen, if you would, obviously this homework is going to be due by the end of the day. Make sure you get that thing done for me. But if you would, if you do not already have them out, I'm going to need those notebooks out and open. There is one particular problem that is not on the homework that I want to do with you before I do this introduction of graphing. Today is the 22nd. There we go. And I'm going to call this add, subtract, bonus problem. Just to kind of walk you through what this problem has in store for us. Okay. X over x squared minus x minus 30 minus 1 over x plus 5. That's the problem. It's an adding and subtracting bonus problem. Now, what I would like to do is this. I would like to find a common denominator, bring this crap together. Oh, these two denominators do not agree with me. I don't like them. Well, actually, no, I do like them. I lied. But you don't like them. There's something going on with these denominators. And unfortunately, you're not going to be able to find out what is going on with these denominators until you factor. You need to factor. We need to factor this problem before we can take the next step. Here's what I'm going to do. First, it shouldn't take that long to realize that the first fraction will factor into the following. 5 times negative 6, 5 plus negative 6. The second fraction I didn't change. This is similar to a problem that we did last class where we took a 3m out of the bottom and found out, oh, they both had a 3m in common. But this time, when you factor it, I need you to recognize that they both have an x plus 5 in common. They both have an x plus 5 in common. And because of that, I can do this. Because they both have an x plus 5 in common, I don't have to worry about the x plus 5. Instead, I can force common denominators by multiplying that second fraction and forcing it to have the same denominator. So, when I bring these together, this is what's going to happen. They will have the same denominator of x plus 5, x minus 6. But the numerator is going to look like this. Which I'm going to have to fix it in a moment. I'm going to have to fix that numerator in a moment. But I wanted you to see how they came together. recognize that you are distributing a -1. And because you are distributing a -1, the following takes place. That really should be x minus x plus 6, in which those x's now cancel each other out, leaving you with 6 over this denominator. See, once you find, sorry, that should have been minus right here. There we go. -6, -6. There we go. Once you find that common denominator, things don't change. Once you find that common denominator, it pretty much stays the same throughout the rest of the problem, unless something simplifies. But in this case, it did not. Craziness. Craziness, craziness, craziness. All of that combined should be enough to be able to get you into that minor assessment that I am going to be throwing at you at some point today. So you'll see. It's going to be on quizzes. You're going to have a few attempts to get that thing done, and we'll move forward from there. Okay. So you have that homework. You're going to hit that assessment. What I would like to do now is I would like to walk you through a little bit of the introduction to graphing. What I'm going to need from you, I'm going to need, if you do not already have them out, I'm going to need those Chromebooks out as well. Ladies and gentlemen, you're going to need to log on to those Chromebooks because I need you to go to a certain website, and it is not quizzes. I want to do an introduction to graphing, but I want to do it using the best graphing website in the existence of the internet. So if you do not already have those Chromebooks out, break them open because I need you to get used to this website. I need you to go to desmos.com. DESMOS.com. I'll type it into the chat. Desmos.com. There it is. I need you to go there. It would be to your benefit if you logged on. You can actually log on using your school Google account. You can log on using that. It would be fantastic because then you could like save stuff. You can see right here. I got my account right there. It's fantastic. And once you log on, it says, let's learn together. Go to your graphing calculator and you go to this screen. Please make sure that you do so. I want you to see what the heck is going on with this thing. First thing that I want you to type in is this. Y equals 1 divided by x. And if you type it in exactly as I just said it, with those commands, y equals 1 divided by x, you get the following graph. Now, this graph is ridiculous. This graph is ridiculous. This graph is known as the basic rational graph. It is an inverse graph. 1 divided by x is technically also known as an inverse graph. But this graph is made up of 2 distinct and separate curves. This curve right here, this curve, never, ever touches or comes into contact with this curve up here. They will never cross each other whatsoever. Yet both curves were created by one equation. They were both created by that y equals 1 over x equation. It is really messed up. Check this out. If you go down here, check this out. You can go down to the second expression. Do y'all have that plus sign in the top left? Click the plus sign and go down to table. Click the plus sign and go down to table. Okay? And you should get something that looks like this. It's a little x sub 1, y sub 1 situation going on here. I'm going to put the number 2 in. I'm going to have to change this. Chapow. Oh, come on. Why aren't you doing things? Oh, I know why it didn't work. Let me double check. I got to check one thing, and I can know exactly why it didn't work. Yep, that's why it didn't work. Instead of y, you need to use f of x. I apologize. I didn't realize Desmos was going to be that fickle about it. But instead of y, you need to type in f of x, f parentheses, x parentheses. And then when you introduce that table, you need to do the same thing right here. You need to change that to an f parentheses, x. Get rid of the little subscript if you can. Oh, this website. But you can see right here at the number 2, it works exactly the way that we believe it will. You take that number 2 and you plug it in for x. 1 divided by x becomes 1 over 2. So it's 1/2. And you can see that thing sitting pretty right there. I could type in the number 5. If I typed in the number 5 into the next location, you can see that it pops up right there being 0.2, which is nice. I could even type in the number, 0.5, and you can see it right there. It pops up as 2, and each of those points immediately pop up on your graph, which is really nice. Somebody type in the number 0 for x. Type in the number 0 for x. What the heck happened? That noise, goodness gracious. Oh, let me just take a quick peek at what they're doing. They're moving all of the art projects out of the way. What the heck happened when I plugged in a 0? What does that mean? What the heck is undefined? Look, I plugged in the 2 and it gave me this. I plugged in the 5 and it gave me this. I plugged in that 1/2 and it gave me this. When I plug in the 0, where on the graph am I? Where the heck am I? Give me a negative number, a small negative number. -4? Sure. Watch what happens when I type in a -4 into the next one. -4. Well, look, it's there. It's there. It's right there. It works. -3. Look, it's right there. -1. Look, it's there. It's on the graph. What the heck is happening at 0? Where am I if I am at 0 on this graph? Yeah? So where am I? It's a weird answer. You ready? You're nowhere. You're literally nowhere. It says undefined for a reason. Tell me, this function is f of x equals what? What did we set this equation as? It's f of x equals what? What did we set it as up here? What happens when you do 1 divided by 0. What have you been taught? Ooh. What have you been taught? 1 divided by 0. When you try in your graphing calculators, to do 1 divided by 0, watch what happens. There it is right there. Chapow! You can't do it. I don't know what you've been taught in the past, but you are not allowed to divide by 0. You're not. Now, you told me that I was in the middle of the graph, I think, right? And I said, but like, where am I? I'm nowhere. Because the thing is, as I travel, check this out. This is one of the absolute most messed up things you will ever see. Think about traveling on this graph. When you travel on a straight line, it is an unbroken straight line. When you travel on a parabola swoops down and then eventually swoops back up. Fantastic. When you travel on an exponential might start up way up here, an exponential decay, and you will slide all the way down, and eventually it'll flatline, but it'll keep going forever. Watch this. If you travel on this graph, it keeps going down and 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 down forever, and it never stops. It heads towards negative infinity, which is not a number. It keeps going down forever, 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 and then magically, in an instance, you disappear, and then you reappear way up here. And then you continue on your way. That's what this graph does. It is absolutely insane. What happens is that the graph approaches something that you've heard before. The graph approaches a concept that we have talked about before. It approaches an asymptote. And an asymptote is a magical thing. Because in this instance, the asymptote actually forces the graph to disappear from down here, poof, and reappear up here as if by magic. But that is literally what is happening. It is literally what is happening. Watch this. I want to show you something on my calculator right here. Check this junk out. Watch this. Let me reset this junk. Here we go. 1 divided by x. Look at this table of values right here. I'm going to do this table of values, but I'm going to do it by, I'm going to start at -5, and I'm going to go by I'm going to go by 0.2. There we go. There we go. Look at this. Look at this. Look at this. This graph. Here's the graph right here. Woo! There's the graph. It's right there. It's the exact same graph. But look at my table of values here. Look what's happening to my y values. What's happening to my y values? You tell me. What's happening to my y values? Yeah, they keep going down. It's like -0.4 and -0.5 and -0.6 and -0.8, -1 and -1.6 and -2.5 and -5 and oh, I reached an error. You said they keep going down, and they were. And then magically, positive. Magically, it's a positive, right? It's not magic, it's math. But that's literally what this graph is showing you right here in red. It is insane what this graph does. Okay. Ladies and gentlemen, as I stated before, I wanted to give you a brief introduction to graphing, and that's exactly what we're going to do. So if you would, I'm going to have you leave your Chromebooks open because I'm going to have you do something on Desmos in a few minutes. But I'm going to have you have those notebooks again out and open. This is an intro to graphing rationals. This is an introduction to graphing rationals. A simple rational graph is, I'm going to do f of x just to stay consistent with Desmos, but it's f of x equals 1 over x. A simple rational graph is f of x equals 1 over x. And I'm going to have you sketch what that graph looks like. I'm going to create a little XY plane right here. I'm going to have a curve that flat lines going to the right. And technically, it flat lines like that up above. And the same thing down here. It flat lines in each of those directions as well. This graph has 2 asymptotes. This graph has 2 asymptotes. A vertical through x equals 0 and a horizontal through y equals 0. It has a vertical through x equals 0 and it has a horizontal through y equals 0. Now, on Desmos in a moment, I'm going to show you how you can actually adjust the locations of those asymptotes. It's really insane where you can place them and what you can do with them. It's rather awesome. But that is what this graph has. It has 2 asymptotes. Now, it's really messed up to think about this, but graphs can technically have as many asymptotes as you want. I'm going to show you that in the future. That's not really what today is about. Let's go back to Desmos. I can X that out, and I can go back to this function right here. Give me a number, any number, positive or negative, make it single digit. 9. Give me a second one, positive or negative, doesn't matter. -7. Cool. X plus 9. Notice that I put that x plus 9. I got to change the 9. Make the 9 a smaller number. 4. There we go. Much better. Much better. Much better. There we go. Made the 9. Made it a 4. Made it a bit better to look at. Look what I did right here. This is the function. I'm going to write it a bit larger right here. Make sure that you can type this in. Make sure you know how to type this in. I typed it in exactly like that. It is the exact same graph. It's the exact same graph, except it has been shifted. It's literally been shifted, but it is the exact same graph. It's been shifted 7 units down, and it has been shifted 4 units to the left. The reason for the direction and the number is because of the numbers that you guys gave me. It has been shifted 7 units down and 4 units to the left, but it still has that vertical asymptote and that horizontal. It follows the exact same things, the exact same characteristics, where it dips all the way down here and then miraculously disappears and reappears up here to continue on its curve. It is insane. It is ridiculous. But that is what this thing does. Here's what your responsibility will be. When we graph anything in this chapter, the calculator, or more specifically Desmos, will do most of the work for you. It will do most of the work for you. Your job is to be able to correctly identify asymptotes, x-intercepts. Eventually, I'm going to introduce to you a concept known as holes. It's going to be insane. I actually want to put this example directly into our notes. So let me show you what you can do with this. So, in my notes, let me flip this over. Here we go. I am going to have the function 1 over x plus 4 minus 7. Now, here's what you are going to be responsible for doing. We need to combine both terms with common denominators. We need to combine both terms with common denominators. That is what we need to do. See, right now, when you have this function just kind of sitting there, it's technically two separate terms. It's a fraction and it's a minus 7. I don't like it. Would much rather put this into a single fraction, and it will make our life 1,000 times easier for understanding what the heck is going on. So, as we've done in the previous section, that 7 is technically over 1. And we can easily find a common denominator to bring the two of these fractions together. It's going to get a bit dicey, but again, I want to show you how you can do this. And again, I need you to have the practice with typing this stuff into Desmos, which I'm going to show you how we can put the simplified version into Desmos. But ultimately, this will be a fraction over x plus 4. But it'll be 1 minus 7x minus 28. We need to recognize distributing that negative 7. Negative 7x minus 27 over x plus 4. So here's what we've done since you've been gone. You ready for this? This was the problem we just typed into the graph, right? With the numbers that you guys gave me. What you guys are going to have to do is, as I've written here, we need to combine both terms with common denominators, as we've done in the previous section. So finding those common denominators, I wrote them in red, what I was multiplying that second fraction by. And ultimately, I was able to get this thing simplified into a very weird-looking fraction. But that fraction is what I need. That fraction will be able to tell me everything I need to know. That fraction will be able to tell me exactly where my horizontal asymptote will be, where my vertical asymptote will be, where my x-intercept will be. It will tell me everything. Your job is to simplify it into a single fraction if it is not already. Let's go back to Desmos. Because what I'm about to do, about to take this circled answer and type it into Desmos. I'm going to leave my first fraction there, my first function there. And this is what I want you to do. For the second function, I want you to do g of x, do g parentheses x, because you want to call it something else. Don't use f of x twice. It'll mess up Desmos. Parentheses. You need to open up a set of parentheses for the top of the fraction. Negative 7x minus 27. Close those parentheses. Divided by, and if you notice when you do divided by, it immediately creates that fraction jumping to the bottom of that negative 7x minus 27. You need to type this in correctly. Parentheses x plus 4. Close parentheses. Let me do something here. Check this junk out. Give me a number. Any number you want. Yay, we love numbers. Type in a 4. I'll type in a negative 8. I'll type in a 9. What I'm showing right here, number one is how you can create a table of values. But number two, more importantly, I'm showing you that f of x and g of x are exactly the same function. They're exactly the same function because they're getting the exact same values when you type in any number for x. Yes? You can. This could be like a, did I do it right, kind of situation. And if you did it right, then this will help you determine that. I got to tell you, what most people are going to do is they're not even going to bother checking to see if they're right. You know what I'm saying? That's what most people are going to do. And for the most part, I might just skip over that. But this is just checking to see if you're correct. Just notice again the table. You just have to put in like a third column for the table and do g of x. Desmos. I love Desmos. Desmos is an amazing function. All right, check this out. Click, click, click. Get rid of all those. I'm going to type in a brand new function. I want to type in, and I want you guys to do this as well. I'm going to show you what I want you to type in. I want you to see if you can type it in correctly. I want you to see if you can type it in correctly. Oh, that is awesome. Maybe not that one. Definitely not that one. That one. Good. Flip. Type in the following example into Desmos. I want to see if you can do this. F of x equals x squared plus 2x minus 3 over 2x squared minus x minus 3. I want to see you type that into Desmos correctly. You need to get practice using that website because it is going to be helpful with figuring out these problems. Now, obviously, I have not typed it myself into Desmos just yet. But if I'm correct, then you should see something rather interesting if you typed it in correctly. Now what I'm going to do is I'm going to freeze my screen. Click. I'm going to leave that up there for a moment. And I'm going to type it in myself. Couple of suggestions just in case you're having a little trouble with this. Couple of suggestions. Number one, your caret symbol. Is your caret symbol like shift and then the number 6? Cool. Number two, after you type in the exponent, do you click the right arrow to get out of the exponent? I know some people do. I don't think a lot of people do, though. I think some people get messed up there, and it's going to mess people up. Here's how I typed it in. Boom. Oh, you can't see it. Boom. Unfreeze. Boom. That's what it should look like. That is what this thing should actually look like. A reminder, again, for when you're typing this thing in. I would do parentheses, X, caret symbol squared, but then you have to dash to the right in order to do the next plus sign. Otherwise, you are going to accidentally have the plus sign up in the exponent. You need to know how to use this website correctly. I'm smiling. Remember how before, for the other example, I said that they were two curves that were distinctly separated from one another. They did not touch each other, but it was from one equation. This is one equation, right? Here's one curve. It disappears. It reappears. Yep. It disappears. And then it reappears. They are three disconnected curves. One equation. I know. But now here's the key, though. It actually has, remember before I said it had two asymptotes? This one has three. There's one asymptote approximately right here. There's one asymptote approximately right here. And there's an additional asymptote right there. Now, if I were to erase this, all these extra lines here, you would be able to see it a bit more clearly in the blue. Because if I put the asymptote right here, you can see that they flatline at the asymptotes. They flatline back here. The middle one goes through it, but that's just a consequence. And then the vertical one, like I said, you can see it a bit easier there. And you can see it a bit easier there. But it actually has three asymptotes. It can have as many as it wants. It depends on the equation. This was a small introduction to what these things look like. Small introduction. We are going to be using Desmos a bit more when we graph them. Remember that homework is due today. I am going to be posting a minor assessment from the problems, well, not from the homework problems, but of similar problems on quizzes. And then we will pick up with more of this graphing on Monday after you have had a full belly from lunch. If you have not left a comment in the chat, please make sure that you do so. Bell's going to ring in a few moments. I'll leave it open for a few moments after that. Bell is off by half a second. Number one, you're not the only one. Number two, the final limit term on link it and link it. It's a terrible website. Number three, you said now, I'm assuming there are two separate questions that you're asking me right now. Yeah. Question number one, I'm just going to guess at these, not guess at these, but reword them. Number one, you're hoping to know what you have to do to perform well on the final exam.
Yeah.
Number two, I think you're asking me what you would need to get in order to maintain the grade that you want to get.
Yeah.
Yeah, that's what I kind of figured. A second.
Allison McMahon, please report to the main lobby.
Oh, yeah. Ooh, sorry, not to, yeah, because clearly you're doing fantastic in the marking periods. You're not the only one that kind of like, on the midterm examination. Let me see something here real quick. I have a meeting that I have to get to in a few minutes, but I can do this real quick. Okay. Between the fourth marking period and the final exam, you would need to average between the two of them approximately a 92 in order to maintain an A for the year. Now, one is worth 20%
Ms. Stevens, please
and
report
one
to
is worth
C109A.
10%. So like, for example, if you got
C109A.
91,
Thank you.
95, let's just say, obviously fourth mark period start. But if you got that, and then let's say you got another 52, let's just say, I'm just gonna make those numbers up, okay? So, 6 plus 5 2 plus 1. Yeah, that would give you an 86 for the year. So if
Yeah,
you,
B, like, I don't mind if I even get a B, I just don't wanna get below, at least so I can see, I'd rather.
oh no, there's no chance.
Oh, you didn't.
There's no chance you drop to a C.
Oh, okay.
There's absolutely no chance. Trust me on that. If you were to get a 95 for the marking period, you would need like an 84 on the final to maintain the A for the year, or something like that. Yeah.
That's fine. It's something like I don't know what I'm doing, it's just that like, with midterms and finals,
Yeah.
it's not like, if I was only taking your test, then it would be easier, but I'm taking some of the tests,
I
and I'm
know.
also trying to study for it, so,
I know.
so it's just,
Well, let me just put it this way. Obviously, I'm going to try and get you guys prepared as much as humanly possible for the final exam. I couldn't even think of the words right now. My goodness. Just see one more thing on your summary. Just tell me this 89 is rounded to. Okay. But I'm just saying that based on what you've done in the past, there is you will definitely have a B.
okay, so no matter what I get on the final, I can at least get a B.
Let's say you get a 0 on the final. If you get a 0 on the final and a 95 for the marking period, you have an 81, which is still good. Yeah. Does that make sense?
Yeah, I feel, cause I just look over my, I was like, look at my mark here, like the report card, and I just see, it's your class and history at the bottom of the midterm. Every other midterm I got like maybe 80 on, except for math and history.
I got you.
I'm also looking at my mark degree, even history, I have like 95 and 96, so I don't have a mark degree.
We had to go back as Algebra 2 teachers and re-edit the midterm 3 times in order to
You're
fit.
making it, right?
Yes,
But
but
other teachers aren't even making that now, I think, someone else is making them for it.
I have no idea. But I'm just saying that we had to go redo it 3 times in order to fit our supervisor's specifications. Apparently, it wasn't straight hard enough, according to what she was saying.
Yeah, I heard like for English, my English teacher was like, yeah, we don't even get to like making it. Like someone else is making it for you, and they don't even know like where we stop. There's gonna be stuff on the final that we didn't get to.
I don't know about that. I know that we're making it on Linkit, but Linkit's just a terrible website. Where are you headed?
I'm just going back.
Fallback? Okay. Okay.
Thank you.
Yep.
Have a good one.
You too.